Hello everyone. Today we will be learning object-oriented programming in Go programming language. Unfortunately, Go doesn't have the same exact object-oriented paradigm that you will find in like C# or Java languages like that, but you can kind of imitate the same behavior in Golang. So it has some inheritance. Actually, it has inheritance, but it's not exactly an inheritance. Actually, it is more like a duck typing. So what is duck typing? It is duck typing. That's how you write it. Is the analogy is simple. Is if something like walks like a dog, speaks like a dog, then it is a dog. It doesn't have to be like look like a dog, but it is. If it behaves like a dog, then it is a duck. So that's the duck typing. I mean, that's where the name comes from. And then you'll see how that works. But the idea is that we have interfaces and we have structs where we use it to kind of like create class-like objects. And then if you have an interface, as long as you satisfy the interface methods, you're good to go. You don't have to explicitly inherit that interface. So let's go ahead and make some examples to see it clearly. So I'm just gonna, as always, say touch command and create a new file called go main.go, and then let's use our trustworthy Visual Studio Code editor to edit this main.go. All right, so let's make it. So the first thing I'm gonna do, of course, as always, we have our main package and then main function, and that's pretty much all. And we will import packages as we go. But the first thing I want to do is to show you how you can create struct types quickly. So let's say world, or actually planet, and then say struct. And a planet can have like a name, let's say, or I don't know, size. Let's say I don't care, size int, I don't know exactly now, radius, let's say int, I'm just making this up. So what I did here is I created a new class-like structure. It is structure. I mean, struct comes from, it's an abbreviation of structure, struct. So it is a structural data type because it has fields and whatever. So when I create a new, let's say, planet as a world, I can say planet. See, there's no new keyword here. I mean, there's a new function, but it's different. But we have this object literal, and then we can just quickly say 1, 2, and that'll give us whatever we need. And then now we can quickly say world dot. Let's see. What's the problem here? World degrade, not world. Oh yeah, so I can now say, let's say fmt print ln, I don't care, world dot, you can just, well, I think it's pretty fine, world dot say size. And then when I save this, when I run this, actually, let's go back to our trustworthy terminal. If I run this, it gives me 1. So that's one way. That's a way you can do like structs. But the problem with that is, though, let's go ahead and assign this to another struct. So I'm just gonna say world or Mars. I don't care. I mean, let's say world. Okay, and then if I say Mars dot size and equals 2, okay, or let's say 100. To make it more obvious that they're different. And if I run this fmt print ln and then Mars size. So what you're expecting, let's actually run this first. In other languages, in languages like you have classes and stuff, if you run this class, if you run this code, what you're gonna see is this operation that you're changing the size of the Mars will also affect world. But let's go ahead and see how that works here. As you see, it didn't change, the world size here, because structs are kind of like a value type. So when you assign a value or when you assign, each time actually you operate on this planet, you actually create a new object, a new structure. So that's what happens here. I mean, when I assign this world to another variable, it actually copied the content of it. So, and then it assigned the value to Mars, and then any operation on Mars is actually happening on a separate, let's say, a value. So that's a problem. I mean, it's not exact like a class that we were familiar with other languages like C# and Java. So one way you can do this, you can fix this problem is, actually let me do it explicitly first. We can use pointers. The pointers are good so that, for instance, if you want to create a pointer, you can just say this, and that will return the address of your new planet here. So this, of course, as you see, it's now a planet pointer. Of course, I can specifically define this. So let's say world, and then now the planet is a Struct type. And that's how it looks like. The good thing is, though, normally when you access the fields from this planet, what you need to do, like what you could do, say, because that's how you actually use pointers. You always use this star sign and then say, and then radius here, okay? But the thing is, Go, it's just cumbersome to do that, and Go allows you to do just this. So it is working as well. The compiler will read it as a pointer instead of normally like this variable holds an address. So in order to get the reference to the actual value, you had to say, okay, I want to point to that actual value, and then you had to use this. But it is just a convenience for within the language. So and now, of course, a pointer type is a different type than, let's say, a planet. So, for instance, if I defined a Mars variable, but as a planet, but you see that not as a planet pointer, then things will go weird. So let's say world. What happens here? Here. As you see, you try to assign a pointer planet to a normal planet, and it's not going to work. It says cannot use world as type planet as an assignment, because there are two different things. Remember this. I mean, this is two different things, and affects how you use methods, how you satisfy interfaces and stuff like that. And we'll see them as we go. But just remember that there are two different things, and they're not assignable, and they also work differently when you have this, when you add methods to your structs, and when you add a method to, let's say, a pointer type, then it will appear, that method will only appear in the pointer type, not in the actual underlying type. You'll see what I'm talking about later. So what happens here, now we have this guy, and then says, of course, we need to defines a planet type here, and it tells you that you'll omit the type planet from declaration of Mars. It will be inferred from the right side, so you don't have to do, like, there are a couple of ways you can define a variable. Like, there are actually three ways. You can make this like explicitly like that, or you can use this and they'll actually infer from the type from the value itself, or you can just remove this var as well, and then you can just say this. And what happens here is that when you do this, it actually create a new variable, declare a new variable, and then define the value of from the world. Okay, so what we're expecting to see here is that, let's go ahead and run this, and it will tell us what we're expecting. As you see, it's 100 and 100 now, because we are working with pointers, and Mars and world, they're now looking at the same, same planet object, underlying object. But if you do, for instance, I think that's pretty much all. All right, so let's go ahead, and this is how you do things. And if you want to get the exact like a class type of thing, then go ahead and you need to use this pointer, and then this is you tell that I want the I want the address of this planet, and then you assign this address to a world, the world. And I'm not sure how you familiar how much you know about pointers, but if you don't, go ahead and check it out. They're actually really cool, and they're pretty much the same concept in pretty much in every languages. So okay, and we have this one, and we did this. So let's go ahead and now add some methods to our struct. Of course, in C# in Java, you can just add your methods here within the struct or within the class. But here it's different. How you add struct is, let's show you, and you can say. Actually, like extension methods, really. I mean, if you know C# extension methods, exactly like extension methods. What you say here is, let's say P and then planet. Actually, let's do this first. Actually, let's do this first. And then let's say get size, we don't care. And it just returns us, as you see, this keyword, like normally in C# and Java, if you have a method, this keyword implicitly is injected into your methods. That's how you can access the class variables. But here you do it explicitly for yourself by yourself, and then by saying that, let's size, you see. And actually, let's not get size, but I don't know, get product or I don't know, get size times, okay, radius. I know, it just I'm just making them up. It doesn't really matter. Okay, and radius. Okay, so you get this, and if you wanna, let's say, assign, or if you wanna have another method, you can just do it like that and say set size, for instance, and you just say and then accept a parameter here. Of course, you need to specify a return type here, and our return type is int. And here also, what's it saying? Two main arguments to return. Really? Well, that's interesting. I don't know. Oh yeah, sorry. At first we didn't have this return type, so it didn't infer that. I mean, anyways, we fixed the problem. And here, what we're gonna say is we're gonna, of course, say size int, and now we're gonna assign that to int. Okay, this is important, and then you'll see why it is important. I mean, the way it is, we don't have to set this, by the way. All right. So, okay, I think we're pretty much all done. So let's skip this. We don't care about any of these anymore. So what I'm gonna do, we have this planet, right? And then it's, first of all, let's go ahead and save this. And if you say world, okay, so let's run this and see how that works. If it works actually, and fmt print ln. Okay, and now let's run this. Okay, so get size time radius. Okay, so we have this get planet stuff, but the problem with this is this. So let me actually remove all these guys over here, and let's see, world set size. Okay, and then if I say 5, and let's see how that will work. Okay, you see that there's a problem there. I mean, even though I set the size, and this guy, I mean, I don't see that my operation actually affected the world itself. So what happens here is that when you pass this value, you see that you pass this here, and it actually copies it by value. So the size, the p here, you get the p is not the right p. So I wonder if I can just write this like this, print ln and world not the world, but see if that works. I wonder. Let's go ahead and run this. Okay, so, well, never mind. I mean, I need to like use some. I was gonna show you the address, but never mind. It's not happening here. But it's a different thing. So never mind. So when this happens, you need to pass this planet as a reference type or as a pointer. So what you can do here is very simple. This, and now when you run this code, let's see how that works. It's now 10. Because what happened here, the p, the same, we actually passed the reference instead of value, and then when we operate on the p, it actually affected the actual thing, which is this guy over here. So that's why it worked. And so you usually prefer, I mean, depends on which one you prefer, but we usually prefer pointers because they help us to, you know, like save some memory space. And in fact, there are times when pointers are much more way better than memory spaces, but there are also other problems of them, but normally it is like immutable. And then anyways, so it's not immutable, sorry, I mean copied by a value. So it depends on how you want to use it, or how you know, it depends on the situation. All right, so let's go ahead and create our first interface. So since we all know all these guys, I'm just gonna keep them. So let's create our own first interface where we actually but before that though, let's actually do this. I mean, I just want to make sure that we are all know this type embedding. The type embedding is kind of a like somewhat similar to inheritance, but also more like composition model. So let's say world. So this is our new, and then the struct2, and all I do is planet. Or let's actually do this. I mean, if you do like plant p, but planet whatever, or parent whatever, I mean, you have this, right? So you can just like similar to this, you just need to set the parent too. So planet 2. So let's have name and then string, and then when you define this planet, and all you have to do is like you just say instead of this and world, right? And by the way, you don't have to, you can specify names as well. So here we say parent, let's say this parent dot, of course parent is a so you just say parent, right? And then you create a new planet here, and you specify, let's say 1, 2, and then here you say name, and then you say Earth. Okay, so you have this one, and the problem is can I use word literal type world as type planet as in, oh yeah, here. Okay, so you have this one, and now you can do whatever you want. I mean, just composition here, right? But there's another thing you can do. If you don't like this model, like whenever, for instance, whenever you need to access a parent stuff, you just say parent, right? And then you access radius and size and whatever you need. If you skip this parent thing, now we're talking about type embedding. And so what's going to happen here is wait a second. It is the planet here, but now what happens here is that you can now access the name, everything directly from on the world without, but you can still say, like, you can still say planet and then world. It works, sorry, it works, but the idea is that you can now omit the planet here, which is perfect. Okay, so we have this one here, which is good, and let's go ahead and run this guy, and we have this go learning, and let's try it again, and now you see we have this 10 stuff, which is good, so it works perfectly. Okay, so since we have here and we show the type embedding, let's go ahead and I don't care this anymore. I mean, that's one way. You can have like multiple type embeddings like that, and they'll do it. They'll do it. You can like have like one like planet, and you can have, I don't know, galaxy, whatever. All this, you can embed all those types within your world, planet stuff. Okay, so the next step is interfaces. So the way you define an interface is very simple. Again, let's assume that I use iPlanet. I mean, I'm from C#, so we used to, prefix all this interfaces with letter I to make it more obvious to the reader that it's an interface. So let's follow the same convention. I'm just gonna say iPlanet, and then now we just say interface, and that's all. Difference between an interface and a struct is that you actually put the signatures of the methods that you expect to be implemented within your interface instead of defining them like this. So the way I say it, for instance, I say get size. I'm just gonna put the same methods that I already did here. So get size time radius, and that returns integer. Okay, and let's go ahead and say set size, and that returns nothing really, right? Okay, but it accepts a size. Okay, so export it, and then, I mean, the way I do right away, I mean, anything that starts with an uppercase, any symbol that starts with an uppercase is publicly exposed. So if you want to make something private, just make it small, like lowercase, like this, and it will be private. So instead of like using public and private keywords, this is how things done in Go. So we have this one, and now let's assume that we have another method here somewhere, sort of function. It's not a method really. Do something on planet, okay, and that accepts our interface type. So planet iPlanet, okay, and that doesn't return anything. What I'm gonna do, I'm simply going to grab this and then put it here. Of course, I mean, since it's a planet, it doesn't know anything about the implementation details of all these guys, but that is all right. So what we're gonna do, let's not. So the world. So this is iPlanet. You don't have to worry about it. So from now on, I'm just gonna quickly declare our syntax. I'm gonna use as quick syntax like this. So let's say planet, okay, and then this is, or we already have the planet, so we don't care about this. Okay, and then let's say we don't care about this too. Let's say planet. Okay, so we have this. Great. So as you see, it is an interface. But the thing is, as you see, I don't specifically inherit from iPlanet. It just, what happens here, it satisfies this guys. But well, actually, let's see if it satisfies those things. Do something. Let's say do something, and then we're gonna have our world. Not right planet, I think. And then 1, 2. Alright, so what it says: cannot use planet literal as type iPlanet in argument to do something. Planet does not implement iPlanet. Set size method has a point. Okay, that's the difference. That's what I'm still talking about. Planet does not implement iPlanet. Why? Because set size method has pointer receiver. That's the difference. That's where a pointer and non-pointer types differ. If I, for instance, remove this. Oops. If I remove this, you see that now it satisfies it, and that's an important thing that you need to remember. So let's go back and run this and see it's 2. I didn't. So the takeaways is that this is duck typing. I didn't specifically inherit from it, but as long as you satisfy the methods or the interface structure, then you're good to go. If you want to make sure that people are somehow like doing it, I mean, there's one way you can do is that if you, in your planet, you can say iPlanet. Remember what we did before? And so what happens here is field does not. But the problem here is that, as you see that we cannot. I mean, this is the problem. I mean, it accepts it expects you to pass one more thing for the iPlanet here, because you have to. I mean, from the previous example, you know that we had to instantiate it as well, or at least assign some value to it as well in our literal struct initialization code. So this idea is good if you need to have some functional structs that do not have fields, or you can assign some other type, some concrete type to this planet. But this is not our concern here. What I'm trying to say, assume that, I mean, if you had something like this, okay, and then at this point you would have a new planet that explicitly satisfy iPlanet interface, and then that also gives you override whatever you like. So for instance, let's not worry about all these things now, but if I do let's actually return. So what I care is, let's get this one, and then let's assume that we simply do this, okay? And then we have this one, and we don't need any of these anymore because it's all gone. So you see that I didn't implement the whole thing. I mean, I didn't implement the entire method that iPlanet actually wants me to do, because this way I can now simply say I want to optionally override whatever I like. So for instance, like overridden this guy, and then this should be working fine. Let's go back to this, and now you see it's 10. So let's go back. As you see, this is, you know, you can use interfaces without implementing everything. It might have some side effects, or I mean trade-offs. For instance, like what happens when you try to run fmt and let's say println, or fmt, not a println, but let's say planet and set size. I mean, you can run this and see how that works. Say it's at this point it is null. What happened here is that you didn't specify anything. You didn't specify the value of this iPlanet thing, and you try to access a nil interface, and a nil interface does not know anything about this guy over here. So the interface cannot have at this point this one, because I mean you try to access the memory where the interface value is a nil. Okay, so that's simply how you can do inheritance type of thing, object-oriented programming in Go. All right, and I hope it is useful, and I hope you guys like this tutorial, and I may have some maybe incorrect explanations, which I hope I didn't, but you know, you never know. If you see anything like that, please comment below, and then please put your suggestions, concerns, questions, anything in the comment section. And until next time, you guys have a great day.